Great. It's a pleasure to be here. Thank you very much, and I'm honored to be speaking to this type of community. I'm going to talk briefly about sort of how we're using reduced form empirics to think about what the economic costs of climate change might look like. But before doing that, I threw the slide back in there after a discussion yesterday. I think it's sometimes worth it to step back and think about where we are and how we conduct ourselves, how we govern ourselves. And throughout time, there have been major revolutions in the types of technologies that we use, whether it's this sort of intuition that we ought to write down the laws, or maybe this notion that maybe people should be treated equally. We've had these things have changed how we govern ourselves in the past, and we're in the midst of a major revolution now, I argue, which is the use of data and computation to think about designing evidence-based policies. And so right now, it's this approach that we're leveraging a lot in current policy discussions about climate change. The question I think about a lot is sort of how much we should be investing today at this decision point where all these paths diverge in terms of how much we're willing to invest to go along one trajectory or another in the future. And so my job is to try and use data and empirics about what we've observed in the very recent past to help paint a vivid picture about what these futures might look like so that we can make intelligent investments. Now, the reason you do that is because if we are going to invest in transforming our global energy system today, we necessarily are going to be taking those resources away from something else. And I like to point out that we want to keep the kindergartens open, we want the roads maintained, the fire department has to keep operating. So it's not the case that we can just throw all of our resources at the climate change problem. So thinking about what is the efficient allocation requires that we understand how much the climate really matters for the economy. And so sort of the stylized two hypotheses are like maybe the climate matters a lot, which some people have a strong intuition for, other people have an intuition that it matters much less. And this is something people like Montesquieu and Aristotle wrote about themselves. It's actually really hard empirically to do this because the climate itself is an extremely high-dimensional object. Society is very high-dimensional. They interact in many, many different ways, and there are many confounding factors that play a role, so we have to be thoughtful about how we try to measure these things in the real world. Now, what I would love to do is take Seema's approach and randomize, right? If I could have two different planets, and I could heat one up, and then I could just look at what happens and compare the treatment in the control group, then it would be very clear what is the effect of climate change, okay? That's hard to get past the IRB, so instead, what we actually do is we think about this sort of quasi-experiment, something like a natural experiment, where we think about populations that are exposed to different environmental conditions, different climates over time, and we treat a fixed population as a control group for itself at either subsequent or preceding moments in time when it faced a different environment. And then we make comparisons within that population, and that allows us to at least know that the population we're looking at is itself unchanging. The sort of diagrammatic picture for a technical audience, this is in a review article that tries to sort of convey the entire game that we're playing. So, on the top panel A, what you see are some distribution of some climatic variable. You can think of this as maybe temperature. And what actually happens, people experience in the real world, are draws from this distribution. So the distribution of what realizations occur is different if you live in climate 1 versus climate 2. But even within climate 1, you're constantly experiencing many different things. What we're interested in is recovering this object we call the dose-response function. That is basically the function that transforms realizations in this climate variable into some social outcome of interest, whether it's human health or the performance of an ecosystem. That then would lead to some sort of output here of the social outcome over time, which then can be aggregated into its own distribution. Okay? Now, what we observe, the econometrician observes, is he observes the outcome data and we observe the input data, and what we're trying to back out is the shape of this function. Now, importantly, I've drawn the function to be different here. The blue one and the pink one are different, in part because if different societies live in different baseline climates, they will have adjusted and structured their economy to respond to these types of events differently. Okay? So that's the general class of problem that we're in, is trying to do the deconvolution where we're backing out what is the response here to all these different types of inputs here. So just to paint a picture of how we do that, I'll just run through a few examples. We've made modest progress over the last several years, but I think it has led to a variety of insights that are useful and directly applicable to policy. So for example, I mean, this country, no one needs to motivate thinking about the economic impact of hurricanes. But we have thought about this in the past. And so one approach is our approach is to actually first reconstruct what populations on the ground experienced when a hurricane passed over them. So to do that, we actually build a physical model of, here in this case, the wind field of a storm, and then we reconstruct, based on satellite-based trajectories of these storms, what populations on the ground would have experienced for different cyclones. So here you see a super typhoon Joan passing over the northern Philippines back in 1970. We then do this type of reconstruction for all the different storms that are observed around the world. There are roughly 100 tropical cyclones per year. And then we go back in time and reconstruct it for each year in the historical record for which we have observations of these storms. And what that allows us to do is to construct a long data set of what populations' exposure to these events was. And then we match it to social outcome data of interest. So here's just an example from one of our analyses. This is based on surveys of tens of thousands of families across the Philippines. And basically, this is a graph of the probability a family is missing strong walls when our statistical model predicts they should have had strong walls based on a household survey. And on the x-axis here is the wind speed that that household was exposed to 1 year prior. Okay, so it's sort of unsurprising. Storms come through, a large fraction of households lose their walls, and you can repeat that sort of exercise looking at a variety of other durable assets. We see fewer households have refrigerators and toilets. It doesn't really affect their cars, probably because when a storm is coming through, people get enough warning to drive their car up the hill, but they're not moving their refrigerators.
But they're watching TV.
But they're losing their televisions, and this is what we're seeing. And then these destruction of assets actually have spill-on ramifications for the rest of the economy. We see that households readjust their consumption behavior, for example. And here on the right is just one panel showing you how much they reduce their expenditure on nutritious foods like meat, dairy, eggs, and fruit in the subsequent years. So we see households spending over a third less in bad years on those nutritious things. That has other effects for health and other members of the family that we document. But this is also important sort of in a macroeconomic sense. You know, you have these large storms coming through, and there's always this debate about whether or not a community or a country is going to recover. We've been having that debate in this country. And if you open up any World Bank report, you see a graph that kind of looks like this, where there's sort of 4 different stylized hypotheses that different macroeconomic models have sort of put out there. And the idea is that you have economic growth in a country, so on the y-axis is GDP, some sort of disaster strikes. So there are a class of theories that we sort of call just the creative destruction ideas, where like you hit a country and somehow perturbing people's normal habits is good because, you know, maybe I talked to my neighbor and we suddenly realized that we could do business together because we're both moving the tree off of our lawn together, and sort of something new and innovative emerges out of that. Okay, so there's one theory that it could actually be good for the economy. There's this build back better idea, which is that the economy underperforms for some period of time, but then in the rebuilding effort, it actually benefits and it more than compensates so that you're on this higher trajectory in the long run. A lot of people think this might happen because, for example, we don't replace capital at the efficient rate. So like I had a phone for a long time. It was this really clunky Android phone. I really hated it. It was bothering me all the time. Then one day I dropped it. It broke. I bought the new iPhone. I was suddenly vastly more productive. I should have actually done that a long time ago, right? But I was updating my capital at an inefficient rate. So that's one theory. A third theory is this idea that you underperform for a while, but then eventually you recover to your trend, where the trend represents some fundamental aspect of where you sit in the global distribution of innovation or something. And then there's this last theory that there's just no recovery, and you just fall relative to trend, and we're just on a permanently lower trend. So these theories have been floating around for a long time. They have a lot of ramifications. I showed you there's over 100 storms per year around the world. We reconstruct the storms for all different countries, and what we see is that cyclones hit a country, and then they decline, their growth declines relative to trend for roughly 15 years, after which it appears to stabilize. And so at least out to 20 years in the data that we can look at, it appears that we're in this kind of no recovery regime. Okay? Now, these costs, you can recover them in any basin around the world. You can recover them for rich countries, poor countries. It's an incredibly generalizable result. And so based on how consistently we recover it, you can say, like, you can play the game where if we turn up cyclones and also turn them down in the Indian Ocean, where they're supposed to decline in intensity, the global projected costs in net present value are roughly $10 trillion that we should value those changes at today. A $10 trillion loss. I think it's worth pointing out, sometimes these costs are thought of as like these abstract ideas, but we're increasingly just seeing them with our own eyes. So this is just, a colleague asked me to do a reconstruction of Hurricane Maria, and it led to this discussion. My eyes popped open. I said, the economic analog to what just happened to Puerto Rico is basically like taking, about 10 kilometers worth of B-52s and firebombing the entire country, okay? So most of the island was exposed to wind speeds over 120 miles per hour. And if you plug it through the machine, what you see is that we estimate that roughly 20 years of economic growth were destroyed in less than 12 hours, okay? So this is essentially the most rapid destruction of economic value short of something like nuclear weapon use. So shifting to another class of issues is to think about whether or not these types of large-scale economic perturbations can really destabilize societies. And so in the past, we've thought about, historians have pointed out that, for example, the Akkadian Empire collapsed during a very dry period. And we notice that around the world, you see similar sort of events where large collapses of populations coincide with large climatic perturbations. So we asked the question, could we see any type of response like that in the modern world today? So we exploited the El Nino Southern Oscillation, where the sort of planetary climate flip-flops on an annual basis. And basically what happens during an El Nino event is that there's a large release of warm air over the tropical Pacific that then propagates around the equator in an equatorial Kelvin wave, leading to heating and drying throughout the tropics that last for about a year, and then the event dissipates and you return to baseline conditions. So what we did is we identified those populations around the world in this red band throughout the middle that are essentially getting slammed by this large atmospheric wave every time an El Nino event occurs. And we call that the teleconnected group. And then there's the regions in the north and south that sort of serve as our placebo group because they're too far north or south to be affected by this large annual oscillation. When we look at this data and we ask what is the probability that countries in these two different samples start a new civil war in any given year, you get this graph, okay? So in the band of countries that are getting hit by this large atmospheric wave, in the hotter and drier El Nino years, the rate at which they generate new civil wars over the last 50 years is roughly 6%, whereas it's half that in the cooler and wetter La Nina years. If you look at the placebo group, those guys that are too far north or south, you see that they produce civil wars at a fairly steady 2% per rate per year, but that it's not in phase with this mode of the global climate. These results, that's just one regression, but they seem to generalize. So in another analysis, what you see here is the result I just showed you on the right, looking around the world, but we can actually look at other data sets. So we can look at countries throughout Africa, we can look at pixels within those countries in East Africa, we can actually look at data sets where we're plucking villages out of a single pixel, and across many different studies, we recover fairly similar results, whereas we shift towards hotter conditions with more extreme rainfall, we observe higher rates of violence at sort of all scales of social organization. And I won't go through these examples, but this result is not just a story about Africa. Even in the United States, when you look at violent crime or even violence in sports, ethnic violence in India, we see these types of results around the world, and they've since been replicated many times by other authors. I want to focus at the very end on thinking about sort of very traditional economic questions. If there are many previous studies, here are two studies by colleagues of mine showing that sort of the fundamental components out of which we build the macroeconomy, so like a maize plant or an individual worker have responses to daily temperature that are not too surprising. So as the temperature rises, we see that yields decline. As the temperature rises, we see that people work fewer hours, okay? And so a question is to ask, how do all these different effects add up and generate costs for the larger economy? And so this is something known as the enumerative approach, where you're literally it's almost an accounting exercise. So what we did is we collected these analyses from a variety of different colleagues. So on the top here, you see the effects of violent crime in the United States. This is the effect of temperature on mortality risk among an older demographic. And on the right are the median projections across the entire suite of CMIP5 models that we've projected to be the impact of each county using these types of empirical results moving forward into the future. And one thing you see, for example, is in cases where this response is completely linear, you get a relatively uniform effect because whatever your temperature was in the past, you just shift to the right a little bit and you get a little bit worse. In cases where we have these really nonlinear U-shaped functions, you get something very different. So in these cases, locations that were initially cold, they actually benefit because there's lower mortality rates during cold days. And then places that are initially very hot tend to be net losers because they tend to be in this part of the curve and they're always going up, right? So we're just accelerating mortality rates in certain locations. We then sort of repeat that exercise, that calculation, for a large number of different previous studies to try and get as comprehensive of a view of the economy that we might get. So we did it for agriculture, for coastal impacts, labor impacts, crime, a variety of these things. And then we start adding them up. So what we did is we aggregate across the country. What are the total of costs across all these sectors in different simulations of the future? So you can take a simulation where there's not so much warming. So these are all the different CMIP5 models under RCP 2.5, ordered based on the global mean temperature that's observed in each model, and the damages to the United States on the y-axis across a large number of Monte Carlo simulations. Then we think about a scenario in which things get warmer, and yet warmer still, and what that allows us to do then is to fit a curve to all of these results and generates an object known in economics as a damage function, which maps global mean temperature onto national economic losses attributable to climate change. And so this is an output that has come from using this type of empirical approach, which then can be applied to integrated assessment. One critique of this sort of entire approach is that we're trying to understand what are the effects of adaptation in the future. Might that mitigate some of these impacts? And it's important to recognize that adaptation might help. However, I think it's generally underappreciated that adaptation comes at a cost, right? We can all sort of walk around in spacesuits, we'll be completely insulated from the environment, but that would be fantastically expensive. So what we try to do is to fully account for both the costs and benefits of adaptation. Now there's a couple different ways to do it. I'll just say one right now. One solution is to take something very different from the enumerative approach, which is sort of this bottom-up idea, and instead to take a top-down view of the economy, where we sort of look at overall macroeconomic performance. And when we do that, we can define something we call the marginal product of climate, which is basically asking what is the marginal contribution of climate to productivity, allowing for all sorts of factor reallocations to occur in equilibrium, okay? Where we think of all those reallocations as basically being different types of adaptation. And the reason this works is because if I take resources out of one use, say I make fewer computers so they can make more air conditioners, there's a cost to the economy because those computers might have been a very productive asset, okay? So when we do that, we actually recover results from the top-down results at the macro level, across countries around the world, or looking at US counties that tend to be fairly similar, where as you warm up, you sort of increase economic output up to a point after which it declines fairly strongly, okay? So there's sort of this sweet spot, and most of the US economy is kind of centered in the middle. But with these results, we actually played a game that let us think about how much does the climate supply, you could think of this as almost, how much value does the climate supply to counties in the United States today, under just historical conditions. And so what you see here is our calculation of how much wealthier individuals and counties are today in terms of the income that they recover relative to just a benchmark, which is the centroid of the country. And so the hotter regions of the country are less productive, roughly to the tune of about $1,000 per capita, and the cooler regions are more productive by about $1,000. You can also take these types of results, and you can do a sort of very simple simulation forecast rolling forward. And what you see is the tropical regions of the world are projected to grow less quickly, and over time that leads to divergence, where places in Europe might benefit, places in South Asia would suffer dramatically. And if you then add that all up together, you can come up with projections for world GDP. So the median projection is roughly a loss of 23% by end of century, but importantly, there's a huge spread on it because there's a tremendous amount of uncertainty. I think that's a reasonable thing to confront. Climate change is going to change the economic environment, and it makes it more difficult to project what will happen in the future. But also, the hotter regions tend to be the poorer regions, and so what you see is a large decline in the poorest 60% of populations, but no effect in the richest. So just to wrap up, we took those results, and to make the sort of future possibilities vivid, we made this visualization, which is our last slide. And all it is showing is the sort of colors indicate global mean temperature changes under business as usual on the left and sort of a strong mitigation scenario on the right. And we've rescaled the intensity of the night lights to reflect the economic growth in those two different types of simulations. So I tell people, you can think about these types of maps and you can say this looks really depressing, I'm really unhappy about this potential future, but I actually tell people the exact opposite. This is the first time in human history where we actually have the computing and the data available to us so that we can see forward, and we don't have to rely on fortune tellers to tell us what, or look at the stars to try and guess what might be happening in the future. We can have an intelligent discussion about what type of future we want to leave to our children. Thank you very much.